Okay guys, I'm going to go over this graphing sheet that you guys got the other day. So first it starts off, it says this is the displacement versus time side. It says the slope of a displacement versus time graph is, and hopefully by now you guys should know how to take slope. Slope equals delta y over delta x. We'll take a look, this is going to be d, and this is going to be t. And on your reference table, you'll find that this is going to equal velocity. Okay, so the slope of this graph is, let's see if I can fit in there, velocity. Yay for Mr. Shaw. Okay, so let's take a look at our very first one. This is an example of constant zero velocity or an object at rest. Now, this can be placed anywhere, but it's just going to be a horizontal line. Let's make it better. I demand better for myself. So just use this tool. And there we go. This is the example of an object at rest. Take a look, its slope is 0, its velocity is 0, therefore it's at rest. Now you could make this line, I only have one color of line to make. You could make this line here. You could make this line here. However you want to make this line, as long as it's horizontal. Good. This is an example of a constant positive velocity. Well, positive velocity means positive slope. So this could be this, or it could be this, or it could be anything. Anything as long as it has a positive slope, and it's a constant positive slope, meaning no curved lines. I know how much you guys love curved lines. Now this is an example of constant negative slope. Let's take some time. Once again, negative slope. So we have constant negative slope, or constant negative velocity. I gave it away. Constant negative slope. And once again, guys, this is going to be a straight line. As long as that slope is negative, it's got constant negative velocity. Okay, now we have to get out the drawing tools, because this is an example of an initial velocity of 0. Very important. Initial velocity 0 with a positive acceleration. Okay, so we have to get out our drawing tool, and I'll choose a cool color like blue. And we're going to have an initial velocity of 0 right here. Now guys, you can draw a couple of these. I like to draw 3. Now you're going to end up erasing 2 of them. I know, and after a while you'll get the hint of it. And it's going to have a positive acceleration. That means it's going to hook up. Now I've made these lines, and maybe when Mr. Shaw, what do these lines mean? These are little horizontal initial velocity lines. That's close to being a velocity of 0 as I can. Now it says with a positive acceleration. That means when you're going to keep adding to this line. So when you add to this line, or you add to the slope of this line, the slope's going to keep getting bigger and bigger. So hopefully, let's just do this. It's a little difficult in this. But this line is going to look something like so. Take a look, the slope keeps getting bigger and bigger. Sorry for the lack of smoothness. Some of you guys are probably pissed off at home for this low quality, but yes, this is a increasing slope, and therefore increasing velocity, therefore acceleration. This is an example of initial velocity of 0 and a negative acceleration. Now hopefully you can get that what this is going to look like. There you go, the exact opposite. Now this part right here should be cut off a little bit. It should start off flat and hook its way down. This is an example of initial positive velocity with a negative acceleration to a velocity of 0. Now this one people always have a lot of problems with, and this is why I usually do multiple drawings, or multiple beginning lines. You have, here you go, 3 positive lines. Here you go, 3, that doesn't look much like 0. Once again, 3 positive lines. 3 lines of 0, and I just pick one that I'm going to connect. I'm going to go with this guy. Up, Control Z. You can do it. Ooh. Okay, I'm just going to do this. Fine, fine. It's going to look like this. Let's see it. This is how I'm trying to get it done, guys. So it would start off, and it's going to look, you're going to have a small line that's going to be positive. And you're going to have a line over here that's 0, and you're just going to connect these. See, it keeps wanting to drag them, and I don't want it to do that. Alright, you will do what I want you to do. So you're going to connect these two. Just imagine that they're connected. And there you go. That's what it should look like. And that's why I draw these lines. So let's take a look at this one real quick. This is an example of initial velocity of 0, or no, initial negative velocity with positive acceleration until a velocity of 0. Okay, but it's all important. It's all highlighted. All right, initial negative velocity. Let's draw some initial negative velocities. Pick my crown tool. Here's some initial negative velocities. Okay. I'm going to make some final zero velocities over here. I'm going to pick, I guess I'm going to go with this guy. Let's see if I can start here. I'm just going to connect him like so. And this is an initial negative velocity, and hooks around and ends up having a velocity of 0. So voila, there we go. We've got that done. We don't have to use the drawing tool anymore. Let's go to the back side. So here we go. Velocity versus time. The slope of this velocity, well, once again, weird slope. Mr. Shaw, why are you wasting my time? Delta y over delta x equals slope equals velocity over time equals acceleration. Very good. So this is acceleration. Not going to try to write and squeeze it in. Now I'm going to go to my line tool. So this is an example of a constant velocity of 0 or an object at rest. Now here is our velocity 0 line. And this one's simply going to lay on top of it. This line that you usually see on your velocity versus time graphs, that is your v equals 0 line, meters per second. Now, this one, the next one, gets a little bit more complicated. It's going to be an example of a constant positive velocity. Well, anything above this line is positive. Anything below it is negative. Simply going to look like that. Okay? Constant negative velocity. Hopefully this is becoming pretty intuitive. Looks like this. And then last, we're getting down to the difficult 4. This is an example of an initial velocity of 0. Now, once again, here's your velocities of 0. Right here, that's a velocity of 0. I don't know what I'll keep grabbing. Control Z. This is an initial velocity of 0 right here. And you're going to have a positive acceleration. So that's going to make it get more and more positive. So you're going to end up something like this. Okay. This is an example of an initial velocity of 0 with negative acceleration. Now, once again, guys, where am I getting these lines from? Once again, remember your slope is acceleration. So this one had a positive slope or positive acceleration, so therefore it has a positive slope. This one, initial velocity 0 and a negative acceleration, therefore negative slope. Okay, an initial positive velocity with a negative acceleration. Positive velocity up here above the 0 line, and a negative acceleration, negative slope until you reach 0. Once again, now here we are. Last but not least, try it yourselves. I won't peek. Okay, you got it. Initially negative velocity starts down here. You can pick anyway. You can pick right here. And it's going to end up on your 0 line right there because it says until a velocity of 0. There we go. We got it done. Great. Thanks for listening.